All right, let's talk stoichiometry. So when we talk stoichiometry, we're now going to start putting things together with whole chemical equations. If I have 3 grams of reactant A, how many grams of product B can I form? These are the types of questions we're able to answer with stoichiometry. All right, so we know that we have our balanced equation. We balance things due to the law of conservation of matter. And so what I put in should be what I get out. Now, one of the things that we will look at when we look into amounts from balanced equations is something called percent yield, because things happen when we do reactions. Maybe something doesn't react completely. Maybe something gets stuck to the side of something else. Maybe you use tap water instead of DI water and you get some sort of weird side product. So there are cases when we don't get an exact 100% yield, but the law of conservation of matter says that we should. Okay, so stoichiometry, we're dealing with quantitative relationships. So yes, we do have to deal with more math here. And so our balanced equations, they let us know exactly what ratios of everything fits together. How much of one thing compares to how much of something else. We know how much we need to add together. We know from all of those numbers what we can end up with on our product side. So we have this definition, stoichiometrically equivalent. Basically, a definite amount of one substance is formed from, produces, or reacts with a definite amount of the other. So I have an amount of something, it's going to react with a definite amount of something else. And when I have that balanced equation, I have this stoichiometry. I have this mole ratio where I have this equivalence of moles of one substance to moles of another substance. So when I look at something like this, I can look at a whole bunch of different ratios there, okay? I can get 2 aluminum for every 6 hydrochloric acid, or I can say I have 6 hydrochloric acid for every 2 aluminum. Okay, I can get every 2 aluminum for 2 aluminum chloride, or 2 aluminum chloride are produced from 2 aluminum. I can get 2 aluminum will produce 3 hydrogen gas, or 3 hydrogen gas are produced when we have 2 aluminum. Okay, I can say that for every 6 hydrochloric acid, I can produce 2 aluminum chloride. For every 2 aluminum chloride that are produced, 6 hydrochloric acid react. I can say that I've got 6 hydrochloric acid for every 3 hydrogen gas, or every 3 hydrogen gas for every 6 hydrochloric acid. And then when I look just at my products, I can say that for every 2 aluminum chloride that are produced, 3 hydrogen are also produced. Or for every 3 hydrogen that are produced, 2 aluminum chloride are also produced. So I can get all sorts of different ratios from a balanced equation. So when I look at stoichiometry problems, the very first thing, most important, write a balanced equation. You cannot solve stoichiometry if you do not have a balanced equation. And then we do some sort of conversion. We have to compare moles to moles, as we looked at when we looked at individual compounds. On the periodic table, I have a ton of different elements, and they all have a different mass. And so 1 mole of hydrogen compared to 1 mole of helium, those have 2 different masses. Or if I say I have 1 gram of hydrogen versus 1 gram of helium, I'm going to have more moles in my 1 gram of hydrogen than in my 1 gram of helium. So I can't compare grams to grams. I have to go through moles. So whatever starting amount I have to go through moles, because to use those ratios, to use that stoichiometrical equivalence within my equation, I have to compare through moles. Okay, we have to compare through moles. And then whatever our target ending is, then we can do a conversion back there. Okay, so here's our flow chart. All right, and so here, this is the important thing. We have to compare moles to moles. Okay, so whatever I have of compound A, I have to convert that to moles in order to use my balanced equation. I use my balanced equation, I get that molar ratio, moles of A to moles of B, and then I can convert from moles to whatever I need for B. Like, let's say I want to know how many atoms of aluminum. Well, okay, I could convert from whatever I started with from A to moles, and then I do moles of whatever A was compared to moles of B from my equation, and then I could use Avogadro's number to get me back to atoms. Or if I wanted grams of aluminum, I could use the molar mass of aluminum to get me back to grams of aluminum. So we have to go through moles though. We will always, always have to go through moles.